Welcome to our Business Intelligence series. Today we're going to look into chi-square. Firstly, we're going to briefly introduce chi-square. Then we're going to look into the terms and formula used in chi-square, and then we'll look into how chi-square is being used. Chi-square is a statistical test for categorical events or variables. It involves the frequencies of the outcomes of the events or variables. So what are categorical data? Examples of categorical data are those data that can be discretely identified. For example, yes or no, whether the value of your gender, male or female, or your preferred color. So the value is very distinct. For example, color can be red, can be purple, and so on. Categorical data is the opposite of continuous data. For example, the temperature, the stock price, and so on. Example for testing categorical events would be we want to see whether there is a relationship between preferred drink and with selected non-communicable diseases. Or you can also check the strength of a relationship between gender and the preferred book type. Chi-square depends on the difference between the observed and expected values, the degree of freedom or D or F, and the selected significance level. Normally, the degree of freedom or D or F and the selected significance level will be given. Chi-square is used to indicate whether there is a statistically significant relationship between categorical variables. Now let's look at the terms and formula. We have the symbol chi here and the squared. Chi squared equals to the summation of the observed value minus the expected values squared divided by the expected values. It may seem quite a formula, but don't worry. Okay. So if we expand this formula, we can expand this observed minus expected to be the summation of for each of the row, okay, and then we go to each of the column. Why do we do this? Because normally the values will be in rows and columns. So we go from each row and for each column. And then we can calculate the expected value for each of the cell, okay, by this formula, okay, and we'll look into how this formula can be used when we go through the example. The degree of freedom, or D or F, is simply the value of the number of rows minus 1 multiplied by the number of columns minus 1. Let's say this is the observed value. Okay, so we have on the left hand side is the name of our what we call the variables, whether drinking coffee or non-coffee drinker, and we have on the top here osteoporosis and no osteoporosis. And these are the values. For example, we have coffee drinkers. We have a total of 75 coffee drinkers, and out of this 75, 35 has osteoporosis and 40 doesn't have osteoporosis. And for those non-coffee drinkers, there are 25 of them. 10 of them has no osteoporosis and 15 of them has osteoporosis. Okay? So the steps in chi-square is to state the null hypothesis, whether A and B are not correlated. So A is the first argument. In this case, this would be drinking coffee, and B would be the argument or the parameter here, getting osteoporosis. So our null hypothesis would be drinking coffee and getting osteoporosis are not significantly related. This is our null hypothesis. So we want to check whether this hypothesis is true or false. Now, given this observed value, we are going to calculate the expected values. Okay. So we are going to create the same table. Okay. Calculate the expected values. We're going to create another new table similar to the one on here, observed values, but we'll name it the expected values. And the calculation to find the value for each cell in the first row and the respective column would be the count A equals to A sub I times count B equals to B sub j. Okay. What does this mean? Let's look at this first cell here, coffee osteoporosis. Okay. So if you look here, it will refer to the first row and the first column. So we need to find the total value for the first row and the first column. So the total for the first row is 75 multiplied by the value for the first column, which is 50, and divided by the total number of observation, which is 100. Then we can do the same thing for the rest of the cells, and you will get these values. So 75 times 50 divided by 100, you get 35.7. For this cell, for example, you have 75 times 50 also, divided by 100, you get 35.7. So this is the expected values, and the top one is the observed values. Next is to find or calculate the chi-squared value, where the formula is the summation of the observed minus the expected values squared divided by the expected values. So we have two tables. The first one is the observed values, and the second table is the expected values. So the formula is to get the differences between the observed values, which is 35, minus the expected values, 37.5, squared and divided by the expected value, 37.5. We do this for all the cells. Okay, so this is the value for the first cell. For the second cell, we have 40 minus 37.5 squared divided by 37.5. And the rest is quite similar to that. And in the end, you will get a value of chi-squared here to become 1.333. This is our calculated value for chi-squared. Next, with the degree of freedom, compare the calculated and the tabulated values. For the tabulated values, we need to use the given values. Okay. First of all, the degree of freedom, we have the number of rows minus 1 times number of columns minus 1. There are two rows here, coffee and non-coffee. So 2 minus 1 is 1. times the two columns, osteoporosis and no osteoporosis. So 2 minus 1 is also 1. So we have 1 times 1 equals to 1. Okay, so the degree of freedom is 1, and given the significance level is 0.01. Using both of these values, the degree of freedom and significance level, we need to refer to the tabulated, to the tables. This is the chi-squared distribution critical values. So this df is the degree of freedom, and the significance level is 0.01. Okay, so we have the degree of freedom of 1, okay, and we have this 0.01 as the significance level, and the intersection of this would be 6.63. So this is our tabulated value for chi-square. So if you compare, we have 1.33 as a calculated chi-square value, and the tabulated value given the degree of freedom and significance level is 6.63. So the calculated value is less than the tabulated value. So the next step is to justify the hypothesis. Since the calculated value is less than the tabulated value, then we accept the null hypothesis. What is the null hypothesis? Our hypothesis is drinking coffee and getting osteoporosis are not significantly related. So we accept this null hypothesis. If the calculated value is larger or greater than the tabulated values, then we reject the null hypothesis. If we reject null hypothesis, then drinking coffee and getting osteoporosis are significantly related. In summary, we have introduced chi-squared. Chi-squared is a statistical test indicating relationship or co-occurrence between two independent events. The terms and formula used in chi-squared are the observed values, the expected values, the degree of freedom, and the significance level. And in the chi-square in action, we have looked into the relationship between preferred drink and selected non-communicable diseases. Thank you very much.